Hello everyone, and welcome to my last video for y'all's admin tutorials. So because in this video we're going to be going over week 4, which is the solving trigonometric equations tutorial. And so if you saw the post, I said that week 5 is conics, and that's actually not going to be required. Now it is unlocked if you want to go ahead and do it as for like a makeup if you didn't like your result or you didn't do another previous week on admin. But you don't have to if you've done these past 4, including this one. There's something else I was going to say with that. Oh, but it's all going to be due by this Friday. Okay, so you cannot do anything next week unless we communicate because of some other circumstance. So make sure you get everything done this week for your classes because grades are supposed to be due on Friday. So if you have any questions about all the logistics, let me know, but I'm going to go ahead and jump into this tutorial. So this is the solving trigonometric equations tutorial. I'm already joined it. So this is slide 1. It's the video. You can watch that if you want. This is what it is. This is your objective. You can watch that introduction if you would like. And then here's an introduction problem. So it says the average monthly temperature of the water in a mountain stream can be modeled by a function. And this is a trig function because it has sine in here, where T of X is the temperature in the water in month X, with X equaling 1 is representing January, 2 would be February, so on and so forth. Suppose you were asked to figure out which 2 months are most likely to have a temperature reading of 62. How would you approach this problem? And then it says you have learned many identities that can help simplify trig expressions. In this lesson, we will review techniques for solving trig equations, apply those techniques to trig equations, and solve real-world problems. So if you think about it, anything that is a cycle over time, so temperature, you know, it rises and then it goes down again and then it rises because it's seasonal, it's cyclical. That is going to be represented by a wave, and that's where trig comes into play because we represent waves and we graph waves with sine and cosine. So any real-world problem that is a wave pattern over time is going to be a trig function that we have to solve. So we will go back to that problem by the end. So the first couple slides are just reviewing how to solve equations, period, because those same strategies we're going to use with just sine and cosine in the problem. So you're going to treat sine and cosine as kind of like your x, because what you do when you solve an equation is you try to get your variable alone. So here is just a review of combining like terms. So hopefully we're good there, but you can review that problem if you need to review that. But I'm not going to do that one. Here's another problem reviewing how to get your variable alone if it's inside a root or a radical. You have to first move over what's not inside the root. So they moved over the -4 and did +4. So that became 5 over here. And now they're left with just the square root and everything inside of it. So then you can square the square root. And then you got to square both sides. Remember, whatever you do to one side, you got to do the other side. And so then you're just left with 3x plus 1 equals 25. And then you subtract your 1, divide by 3. Next one is a review of if it's being squared, then you would first move over the -5 and do +5. Then you would have to divide by your 4 because that is not being squared. So you would divide by that one first. So you're left with x squared equals 5/4. And then you square root to get rid of the square. And then don't forget when you square root the other side, it's technically positive and negative, right? Because if you plugged it back in, if you plugged in positive 5/4 or negative 5/4, when you square it, it's going to end up being the positive version. So just remember, anytime you're solving an equation, if you square root both sides, you always have plus or minus. And then they took the square root of the top and left it square root of 5, square root of 4 is 2. So you have 2 solutions, which makes sense if you look at this quadratic graph. Okay, slide 9 is reviewing factoring. So here you would just use X method because the coefficient in front of X squared is a 1. You say what multiplies to get the last term and adds to get the middle term. You can set up your X if you want. And then you set up your factors, set them both equal to 0 and get your answers. So this page, slide 10, is some just factoring review. So I'd pause the video, go try to do all these on your own, and using different factoring methods that we've done throughout the year, and then you can resume the video and check it. So now that you've tried them on your own, here is number 1. It would just be X method. You'd ask yourself what multiplies to get 2 and add to get 3, which would be 2 and 1. So the factors are X plus 2 and X plus 1. The answers are X equals -2 and X equals -1. Number 2 would be a difference of squares because it was minus, and then you could take the square root of both terms. So the square root of X squared is just X, and the square root of 49 is 7. So your factors are X plus 7 and X minus 7. So then your solutions are -7 and 7. On number 3, you have a coefficient in front of X squared that's not just 1. So you have to use slide and divide, or bottoms up, I think is what most of y'all call it. And so what you do here is you would move this 2 to the back and multiply it by the last term. So then this becomes X squared minus 7X minus 30. And then you do X method like normal. So what multiplies to be -30 and adds to be -7, which would be -10 and 3. But then you can't forget that you're not done because you first multiplied that 2 to the back. Now you divide by that 2. And if it divides to a whole number, it's just, that's your factor now. 10 divided by 2 is 5. 3 divided by 2 doesn't simplify, so we put that 2 in the front of that factor. So if you don't remember that, I don't know if that makes sense, but you can probably look up different ways to do that online. So your two factors are X minus 5 and 2X plus 3. And then your solutions would be +5 and -3/2. Okay, number 4, it's a lot easier if you factor out a greatest common factor. So you could do slide and divide, but it'd be really big numbers. Excuse me. So don't forget though, whenever you factor, it has to equal 0. Anytime you do any of these, it needs all your terms need to be on one side. So you first have to do +18 to move it over. Then you can factor out of 3 from all your terms. So then you're left with 3 times X squared minus 5X plus 6. And then you could just factor the inside trinomial using X method. So then you technically still have this 3 that you factored out, but, oops, I didn't mean to move that. But then when that is not a factor, because 3 can't equal 0. Because when you go from factors to solutions, you're technically setting all equal to 0. So if it doesn't have an X, it can't give you a solution. So you don't really need that outside 3, and your solutions are 2 and 3. Hopefully that was a nice little easy review of factoring for you, because we are going to use factoring, but with trig, which I think we've done in other tutorials. Okay, so here's just a review of solving. So what would you do first is you would first move over the +5 by subtracting 5 from both sides. Then you would need to divide by the 3 because it's not inside the root. You can't mess with that root till you move everything else over. Now we need to get rid of the square root, so we're going to square both sides. And now we look this, anytime you have a squared term and a not squared term, you're going to need to do some type of factoring. So we're going to go ahead and remember to factor, it needs to equal 0. So we're going to subtract 9 from both sides to move it over to the left. Now we can factor using X method. So what multiplies to get -9 and adds to get -8 would be -9 and +1. So then this, the way they word this right here is kind of weird, but what would your solutions be? Would be +9 and -1. And there you go. Okay, so here's where we start actually talking about trig. It says, since trig equations are periodic, there are infinite solutions to an equation such as sin x equals 1/2. So if you think about when you see this equation, you're saying, okay, where on the unit circle would my sine value equal 1/2? And now notice this is not an inverse. So last time when we did inverses, we had restrictions to our domain. We don't have restrictions anymore. You can look in any quadrant. So you're not stuck to just the first and fourth quadrant for sine anymore. So if you look on your unit circle for where is the sine value 1/2, it would be at 30 and 150. But a 30-degree angle is coterminal with 390, 750, 1,110. I said that weird. 1,110. Because what we're saying is, so at 30, the sine value is 1/2. But if you go around again, coterminal means you end at that same spot. You just go another 360 degrees. It's also sine value 1/2. go around again. So there's going to be an infinite amount of places or angles where the sine value is 1/2. And then same thing for the 150 answer. You could go around and keep going around there. So it says, therefore, the solution to sine x equals 1/2 includes an infinite number of angles. So to express all real solutions to your equation, you have to find your angles, which is true on, so they give you this interval 0 to 360. That's just saying on the unit circle. And then you're going to add this to the end of your answer. You're going to add plus 360k. That just means plus going around another 360. Either k could be once. You could go around 2 360s. You could go around 3 360s. So k just represents going around as many times as you want. And then they put this weird notation, which just, then they explain it here. The expression, I forgot what my mind just blanked on how to read that, but you would read it out loud as k is an integer. Why do we add 360k to the solution from the unit circle? Because 360 is significant because it's the period of the sine function, and adding 360k will generate every possible solution. So if they say every possible solution, you need to add that to your answer, basically. So then it says sometimes we don't want every possible solution to a trig equation, but rather only the solutions in a particular interval. In such cases, it's not necessary to add that. For example, if they give you this, tan x equals negative square root of 3 over 3 in the interval 0 to 360, then we just want, that's just saying, okay, what angles on your first rotation of the unit circle will tangent x equal negative square root of 3 over 3? Okay, so you don't need to add that. It's just saying, okay, just the original unit circle, where would tangent be negative square root of 3 over 3? So hopefully by now you're recognizing that that's rationalized. And so you kind of have gotten in the habit of figuring out those answers, those tangent answers. But if you go to 150 degrees or 330 degrees, those are the only two answers where your tangent will be negative square root of 3 over 3 once you rationalize it. So if the question had asked for all solutions without putting this restriction, this interval, the answer would have been just the 150 plus 180k. So why is it says notice that that's 180 instead of 360 now? That's because the period for tangent is 180 degrees, or pi. When we did it in class, we did it in radians. Also notice that we would not include 330 plus 180. So if you think about it on the unit circle, your answers were 150 and 330, right? Well, let's think about 150. If you go 180 degrees, that's half a circle, you get to your other 330 answer. Okay, now if you go another 180 degrees, you get back to 150, and go another 180, you get back to 330. So if you just take this 150 and add 180, you'll include this 330 answer. Okay, so if all this is confusing to you, just know this is typed wrong. If it's, sorry. If a problem asks for solutions on an interval, either 0 to 360 if it's talking about degrees, or 0 to 2 pi if it's talking about radians, you just have to give the answers from the unit circle, which you can have more than one answer from the unit circle. But if it says find all general solutions, here's kind of your rule if you want to write this down. You're going to find the angles from the unit circle, and if it's sine or cosine with two answers from the unit circle, you're going to put plus 360k if it's in degrees, or 2 pi k if it's in radians, to both angles. And you're going to have both angles plus 360k as your answer, or plus 2 pi k. Now, if it's tangent with two answers from the unit circle, you're going to put plus 180k on just the first angle that you would reach. And you don't need to list both angles. If it's sine or cosine with four answers, which we'll look at an example like that in a second, then you would just need to put plus 180k to the first two angles. And we'll look at why that is in a second. But this is kind of the rule if you can't think through, should you do 360 or 180? Just, if you want to be careful, I would put both. But you got to think through, how could you reach all your possible answers? So here's an example where it says some trig equations are more complex. Like this was these two that we looked at with sine and tangent were already set up to just be a trig function equals a number. So if it's more messy, you're going to have to solve it just like we practiced solving at the beginning of the tutorial. So if they give you sine x plus square root of 2 equals negative sine x. And if you notice, they say in 0 to 2 pi. So what does that mean? Is our answer is going to be in radians because it's 2 pi, and that just means they only want the answers from the original unit circle, so we don't have to worry about adding that k business at the end. Okay, so what would we do first? Well, we would need to just think about sine x as like your variable. So if sine x was your variable and you had a variable on both sides, you would know that you would need to collect them on one side. So what they did is they did plus sine x to move it over to the left side. So when you do that, you have this sine x plus square root of 2 equals 0 now, because those canceled on the right side. So then we could clean this up, and then they went ahead and moved their number over to the left side, right? You want your variable alone. So your variable right now is your sine of x. So they moved over the square root of 2 by subtracting it. So then on this left side, you have sine x plus sine x. So just think of that as if that was x plus x, well, that's 2x. So this is 2 sine x equals negative square root of 2. And then they divided by the 2 to get sine x alone. Okay, so now as soon as you get sine x alone, you go to your unit circle. And you say, where on the unit circle is sine going to be negative square root of 2 over 2? Because x is an angle. Okay, so we're saying what angle is the sine value negative square root of 2 over 2? Well, if you look on your unit circle, it's going to be at 5 pi over 4 and 7 pi over 4. So those are your two answers. So, we don't have to worry about that because it just wanted on the unit circle. So in this one, it says, when solving trig equations with square terms, taking square roots can be helpful. For example, we have 4 cosine squared minus 3 equals 0. So same idea, think of cosine x as your variable. So cosine x is being squared. Remember they write it weird? Where they put cosine squared x, but think about that as cosine x squared. Okay, you can't separate the cosine and the x. So what they did first, it did the plus 3, which makes sense because that's how we always do it. And then we divide by the coefficient, the 4. So now we have cosine x squared equals 3/4. So we need to square root it to get rid of the square. So we square root both sides, and whenever you square root both sides, you end up with plus or minus now. So now we're just left with cosine x on the left side, and then when you square root a fraction, you square root the top, which is the left square root of 3, and then they square root at the bottom, which was 2. So now that we got the cosine alone, we say where on the unit circle is cosine either positive or negative square root of 3 over 2. So now if you think about it, because it can be positive or negative, you're going to have 4 answers because it's going to be in every quadrant because cosine is the x value. Square root of 3 over 2 is at, I can't remember, is this degrees or radians? You want it in degrees. So at 30 degrees, at 150 degrees, it's negative square root of 3 over 2. At 210, it's negative square root of 3 over 2. And at 330, it's positive square root of 3 over 2. So you have 4 angles where the x value is either positive or negative square root of 3 over 2. Now, but they didn't want just in the interval of your first unit circle, they want all general solutions. So because you had 4 answers, this is what I was talking about here, because you had 4 answers, you're just gonna, for your final answer, put 1 plus 180k on the first 2. Because think about it, if you start at 30, our first answer, and you go 180 degrees, half a circle, you'll get to this 210 answer. Okay, so if you just keep going 180 from that original first one, you'll include this third answer. And same thing, if you take this 150 degrees and go 180, you'll include the 4th answer. So you just need the first 2 and put plus 180k because it's degrees. You would put plus pi k if it was radians. So I hope that kind of makes sense. I really think, though, when you do your test, I don't remember that being that big of a deal. But if you have more questions about it, feel free to let me know and we can meet if that general solution part is confusing you. Okay, so here's one where you need to factor. So it says sometimes we can use factoring to help. That includes squared terms. We'll solve 2 sine squared minus 3 sine plus 1 equals 0 in the interval. So that means we don't got to worry about that general solution K stuff. And we know our answers can be in degrees because that's 362 degrees. So how do we know we're going to need to factor? Just the same way we know we need to factor when it's x, because we have a squared trig function and we have a non-squared trig function. So what they say might be helpful, and I think I did this in another tutorial, is that's kind of hard to keep factor when it's like sine. So what they do is they let u represent sine x. So they rewrite the problem, and everywhere there's a sine x, they replace it with u. So this becomes 2u squared minus 3u plus 1. And now you just factor this like normal. So you would use slide and divide, right? Multiply by the 2 in the back, do the x method, and then divide by the 2. So if you need help with that, let me know. But you should end up with the factors 2u minus 1 and u minus 1. So then you set them equal to 0 and get your solutions of u equals 1/2 and u equals 1. But remember, u was just like a placeholder. U is representing sine x. So now that you got your actual solutions, you replace u back with sine x. And we have sine x equals 1/2 and sine x equals 1. So now that we have our sine x alone, you can say, okay, where on the unit circle is sine x 1/2 and sine x 1? So do them separate. First, look on your unit circle for 1/2. Well, that's going to be at 30 degrees and 150 degrees. And then where on your unit circle is sine 1? That would be at 90 degrees. So it says, of course, not all quadratic equations are factorial, so you might have to use the quadratic formula. I haven't seen one in this where you have to do that, but I guess it's good to know. Okay, so here it says, how would you solve sine x plus 1 equals cosine n 0 to 360, so just on the unit circle. It says a trig equation written in terms of more than one function. In this case, see, we have sine in our equation and we also have cosine in our equation. That's very difficult to solve, so we want to put the equation in terms of only one function. So unfortunately, so how are you going to change that is you're going to use your identities. But unfortunately, there's no identity that converts sine to cosine or cosine to sine. If you look on your formula or your identity chart, there's nothing that says sine equals something in terms of cosine. But we do have, the only one that's close is our Pythagorean identity, where, remember, originally they already manipulated it. But originally the Pythagorean identity is sine squared plus cosine squared equals 1. But to use that, sine and cosine need to be squared. Right here, sine and cosine aren't squared. Sine x plus cosine x does not equal 1. Sine squared plus cosine squared equals 1. So what they did is they manipulated that. I might have put it on a slide. Let's see. So yeah, this is what you start with. And then what we're going to do is get it in terms of sine. So we're going to get our cosine squared alone. Because we have cosine in the equation and not cosine squared, we'll have to do some algebra. Okay, so I know that I can move this sine squared x over, right? Subtract it to the other side. So I know cosine squared equals 1 minus sine squared using my Pythagorean identity. But now I don't have cosine squared in my problem. But I could square my cosine to get it to be cosine squared. But just whatever you do to one side, you got to do to the other side. So I can square both sides. So now I have cosine squared and can use my Pythagorean identity. So the first step is going to be to square both sides. That's what I did here in red. So then I'm going to clean up this left side. So if I square a binomial, I need to actually expand it and write it out twice and then FOIL it. So sine times sine is sine squared. Sine times 1 is sine. Sine times 1 is sine. And then 1 times 1 is 1. And then I just kept this cosine squared over here. Okay, now I combine my like terms. Sine plus sine would be 2 sine. And then I think I jumped into what they were doing. So that's what they have here. No, that's, where do they have that? Here. Sine squared plus 2 sine squared plus 1 equals cosine squared. Okay, that's, I just broke it down more so you could see what they did. They squared both sides and then FOILed the left side and combined like terms. So now we did that originally because cosine squared, we know, is 1 minus sine squared. So they replaced that left side with 1 minus sine squared. So this seems more complicated, but now if you notice, our whole function only has sine, which is better than having sine and cosine. So now what we're going to do is move everything to the left side to see if we need to factor and just combine our like terms. So what they did is they first subtracted 1. Well, if we subtract 1 from both sides, that ends up canceling on both sides. And then they added the sine squared from the right side to the left side. So if you add sine squared on both sides, then you have sine squared plus sine squared, which will get you 2 sine squared. And then you still have this plus 2 sine x, and then the 1's canceled, so it just equals 0. So just move this stuff over to the left side, and you should end up with what they have here. So then if you look at that and we think about factoring, it's not a trinomial, so you don't want to use X method. So you're going to try to see if you can factor out what they have in common. So if you look, both terms on this right side have a 2, and they both have a sine. So we factor out a 2 sine x, and then from the first term you're left with sine x, from the second term you're left with just a coefficient 1. So then those are your factors. 2 sine x, you can set it equal to 0, and sine x plus 1, set it equal to 0, and then get sine x alone. So you end up with sine x equals 0 and sine x equals -1. And then you can go to your unit circle and say, okay, where on the unit circle is sine equal to 0? Well, that would be at 0 degrees and 180 degrees. And then where on the unit circle is sine -1 at 270 degrees. And then they talk about checking for extraneous solutions. Anytime you square both sides like that at the beginning, you could end up with things that don't actually work. So if you plug them back in, you can test and see that that 180 degrees actually isn't a true solution, and 0 and 270 are only true solutions. I wouldn't stress too much about that right now, just because we're not in class to actually go that far in depth and just look at why. But what you're just testing your answers, plug them back into this original and see, does this side truly equal this side when you plug those angles back in. Okay, so here, I don't know why they already put this. That's not right. Okay, that's the original problem. So I'll delete that if it does that to you as well. But it says you need to rewrite this function in terms of cosine. Okay, it tells you what it wants. So that means we need to replace this sine squared with cosine. So let's see. So because we're replacing sine and cosine, we're probably going to use that Pythagorean identity. And what is nice is that sine squared it's already squared. So we don't need to go square both sides like the last problem. But we know sine squared equals 1 minus cosine squared when you move the cosine squared over. So this part's not supposed to be red. So I tried to put it in red to show you everything stayed the same. All I did was replace sine squared with 1 minus cosine squared from the Pythagorean identity. And then because that had a coefficient of 2, those parentheses are important because then you distribute the 2. So that becomes 2 minus 2 cosine squared plus 3 cosine minus 3. Then you can combine your like terms, which is the 2 and the -3 just becomes a -1 at the end. So that trinomial would be your answer. So you can type that in, -2. Don't forget you have to use their cosine x, and then you can put your squared after. Is it positive or -3? Plus 3 cosine x minus 1. And then click done, and that should be correct. You don't have to, notice it didn't want you to actually solve it. It just wanted you to get it in terms of something else. So in this problem, it says rewrite 2 secant squared plus tangent squared minus 3 in terms of tangent. So we need to replace the secant squared with tangent, which is convenient because we have another Pythagorean identity that says tangent squared plus 1 equals secant squared. So again, use your, I don't know why my red is all off, but use your parentheses, and we're going to replace this secant squared with tangent squared plus 1. And then distribute your 2, and you end up with 2 tangent squared plus 2 plus, this was originally tangent squared minus 3. And then you're going to combine your like terms. So tangent squareds our like terms. So we have 2 tangent squared plus 1 tangent squared. So that becomes 3 tangent squared. And then we have 2 minus 3 becomes negative 1. So 3 tangent squared x minus 1. 3 tangent x squared minus 1. So similar one, these are all pretty similar, is it's rewrite cosecant squared minus 3 cotangent minus 5 in terms of cotangent. So we need to replace the cosecant part. So again, that's convenient because it's already squared, and we have another Pythagorean identity that says cotangent squared plus 1 equals cosecant squared. So cosecant squared can be replaced with cotangent squared plus 1. I put the parentheses, but there was nothing to distribute, so we didn't really need them. So you can just combine your like terms. The positive 1 and the negative 5 become minus 4, and you can type that in. So I'm not going to type that one in and just save time. Okay, you can pause the video, delete this, and then type in your answer. Delete all of it, not just write it in. And then we can keep going. Okay, so this one looks a little bit more intimidating, but it's not as bad as you think. It works out nicely. It says, recall your general form that we learned when we did graphing trig functions. Equations are often in this form when they're periodic or seasonal contexts. Let's see how to solve an equation in this form. So it's given f of x equals this equation, and what values x is f of x equals to 240. So that you're going to plug in 240 for f of x. So it becomes your equation equals 240. So now you're just going to solve this. So the first thing you would do is subtract 320. So if you subtract 320, I think you get 80, negative 80, and then you divide by the 160. So you have negative 80 divided by 160, and you end up with negative 1/2. You can type that in your calculator if you need to. So here, okay, so the rule is we have all this stuff inside our parentheses set. You cannot touch anything inside the parentheses set until you've gone to the unit circle. Okay, so you get sign of a mess equals a number. Now you go to the unit circle. Ignore that mess for a second, and you're still just going to ask yourself the same question. Now, what they did is they just replaced all that mess with u, which you can do that as well. So just ignore all that mess and say, okay, where on the unit circle is sine equal to negative 1/2? So if you go look on your unit circle, the y value is negative 1/2 at 210 and 310. So we want this inside mess to equal those two answers because we want the inside mess to be that angle. So you set 60x plus 60 equal to your answers from the unit circle. Okay, the stuff inside the parenthesis needs to equal the angle you want. And so then you can solve those, subtract the 60, and then divide by the 60 for each one, and you should get 2.5 and 4.5. So just keep that in mind. Do not touch the stuff inside the parenthesis until after you've gone to the unit circle. You set it equal to the angle from the unit circle. I cannot stress that enough. Okay, so here's where they start to show you how to graph to solve problems instead of algebraically, which is a great tool to use, but you can't always use it, especially if you're taking AP Calculus. So it says you can also solve trig equations on a calculator by graphing and finding the intersection. So for this one we just did, f of x equaled that equation, and we found the values for 240. So using your graphing calculator, make sure it's in degree mode, because that's how this problem is. Sometimes it'll want radian mode. You're just going to graph both things. So you're going to graph that equation, and then you're also going to graph the answer you were looking for, 240, as another equation. And then sometimes it's talking about how it's hard to find the right window, so you can use how we know where the midline is at 320 and the amplitude. So that's going to give us how high to look on our graph. And the period will give us how the x kind of axis we want to look on our graph, the x window. That's the word I was looking for. So you can use that to help you. But what I was going to say is you're going to use Desmos if you're going to do these graphing problems. And Desmos is pretty easy to find your graph, but I can show you how to change the window if you need to. Did I do this one? I can't remember. No, I did not. because they already gave you the graph. But if you graph it, this is your trig function, and then y equals 240 would just be a horizontal line. And you can get these two intersection points right here would be 2.5 and 4.5, which was the same as the last problem. So here you're going to solve all these by graphing around your answer within your thousands. So to save time, I already graphed them in Desmos. So you can go to desmos.com and then you'll click start graphing and you can get to the page I'm on. So sometimes if you look, you can just copy, like highlight, and then push Control C on some of these. But like the question 2, you can't do that. So you have to type it in, which takes some time. But I went ahead and typed it in already. So you graph them separate. Don't graph, you can't graph an equal sign, okay, because it's already y equals. You don't have to type the y equals, you can. You don't have to. And you graph the left side of the equal sign and the right side of the equal sign, and then you find those intersection points. So if you look, and what's the x values? So negative 1.798, negative 1.076, and 0.626. What's nice about Desmos is you can just click and it'll give you those intersection values. And you will just type those answers in here and then check your answer. So make sure you actually type them in, but just to save time on the video, I'm not going to type them. Just pause the video and type them. Okay, so here again, this would take some time to type in, but you'll have to type in the left side, then type in the right side. And now if you notice, oh, I didn't talk about this on the last one. I should have talked about on this one because you notice it said radians here. So you want to make sure your graph is in radian mode. Well, if you click on this wrench, down at the bottom, you can make sure it's in radians. Okay, so how do I know this one? The second question didn't say radians, but if you see stuff in terms of pi, you should know that that's going to be radians. So we want to make sure it's in radian mode, which Desmos starts in radian mode. Okay, and if you couldn't see your graph, this is where you can change your window. You want for your x-axis to go from whatever value to whatever value, and your y-axis to go from whatever value to whatever value. But you can also just scroll on Desmos pretty easy. But ours is right here. We can see that there's 3 intersection points right here, and right here. Now notice they give you the x-intercepts also, so make sure you don't use those. Just use where both graphs are intersecting. Should be negative 1.812, negative 0.978, and negative 0.22. It wants the x values. And then type those in there and click submit. Okay, question 3. If you take the left side and you take the right side and you graph them, this one, it wants degree mode, right? Because that was 90 degrees. So if you look at this, that looks like a mess. That's because it's in the wrong mode. If you change it to degrees, it's a lot clearer. And we can see the intersection points are right here, negative 1.138 and positive 1.138. Type those in, and then you can self-evaluate. I'll do that later, because it's going to ask me if I want to save. So here's just talking about a real world problem. It's always hard for me to say. That they can model harmonic motion, such as weight oscillating at the end of a spring, because it would change its height. So it's like cyclical. It's going up and down and up and down. So here is this function that they defined it, where y is the displacement in meters and t is the time. So y is just giving, so it's the displacement from the top of so it's going closer to the top of the spring, down, up, down, up, down. And so y is giving the distance that end is from the top of the spring. That's the displacement. And t is the time. Let's find the values of t where the displacement is 0. So we'll solve this problem with a graphing calculator. So same idea is we're going to graph it in radian mode. So here we graphed it. And that's pretty nice. So we don't have to worry about the window. The rest of this is just talking about trying to find the right window. So you can read that if you want to. And then we want to know when y equals 0, when the displacement is 0. So that's just, you could type that in if you want, but that's just the x-intercepts, right? So if you're going to do a number, just make sure 0, you can't just type in. You have to do y equals 0. And then you can get these intercepts. which is what they listed there. So here is a problem where it says another real-world phenomenon that trigonometric functions can model is projectile motion. The range of an object shot by a cannon is modeled by this equation where v0 is the initial velocity and theta is the angle at which the object is shot, right? How high the cannon's pointing. And it gives us initial velocity, our v sub 0 is 80. At what angle must the object be shot to reach the target 100 feet away? So we're solving for an angle, so we're solving for this theta. So the first thing they do is they plug in the stuff we know. Well, they told us our initial velocity, our v0 is 80, so that we plug that in for that. And then we want to know when it reaches 100 feet away, so they plugged 100 in for r. And now they just simplified these numbers in front of the sign. So 80 squared times 1 over 32 would get you 200. And so now you're going to start solving this. So if you're solving for theta, you got to first get your trig function alone. So you divide by the 200, get 1/2. Now remember, you cannot touch that stuff inside of the parentheses set until after you've gone to the unit circle. So you say, okay, where on the unit, ignore the 2 theta for a second. Just say where on the unit circle is sine 1/2, which is 30 and 150. So you set 2 theta equal to 30 and you set it equal to 150. And then you solve for theta by dividing by 2. So theta equals 15 and 75 when you divide both angles by 2. So here it says the Ganges River empties into the Bay of Bengal. Its discharge rate from May to December is modeled by this equation where t equals 1 represents May 1st. In which months of the discharge rate more than 26,050 meters cubed per second? Select the correct answer. So what would we do first? What is this 26,050 number? That is not your time, but it's your discharge. So that would be plug it in for dt. And then isolate your trig function. So they subtracted and divided. They did not touch that stuff on the inside, right? So now what they say is to help us ignore all that stuff on the inside, they let u equal the argument is the nice mathematical term for the stuff on the inside. So let u represent that, and then you solve for u. Wait, now I'm getting confused. Yeah, you solve for u by going to the unit circle, right? So what angle would sine value equal 0.5? And then you replace u back with all that stuff, that inside stuff, right? U is like a placeholder. It's just u is a placeholder for all that inside stuff. So we set the inside stuff equal to those 2 angles. Notice this is in radians now, and now you're going to solve for t. Solve for all values of t. So you would have to add the 2 pi over 3 and then divide by pi over 3, which it looks like they might have used a calculator. Okay, on this one, trig functions can also model sales of product, particularly products that depend on the weather. For example, a company's monthly heating oil sales can be modeled by this equation where S of t is the average sales in month and t equals 1 represents January. For what months are sales less than 4,000? Let's solve this problem by graphing. Make sure your calculator is in radian mode, then enter the function in y1 and enter 4,000 in y2. And it gives you the period and the amplitude to kind of help you get the right window. So if you think about it, why would monthly sales for something that's based on the weather be cyclical? Because if this is heating oil, in the cold months, they're going to have high sales. Well, in the summer, they're going to have cold sales. And then it just repeats over the years, right? So did I do this one? I forget what I do and what I don't do. What is it, 1600? Here it is, right? Yes. So we want to know when it's less than 4,000. So I typed in my equation. Now, if I want less than 4,000, I'm going to type in y. You have to type the y equals if it's just a number. You can't just type 4,000. 4,000. Now, obviously, y equals 4,000 is not even close to here. So you can go to your wrench and you can change this y-axis to be, I don't know. Can't do it. I'll start with 3,000 to 5,000. And then also though, you can just go up and down if you need to, like to see the top of the graph if you wanted. What I'm doing is I'm pressing and holding and then scrolling. And then if you think about, what does it say? We want to talk about just that first month or that first year, just talking about 1 year. So each month, I can't talk, each T is another month, right? T equals 1 is January, T equals 2 is February, so on and so forth. So if you also wanted, oops, why did I do that? If you also wanted, we could change our window for X to go from, I don't know why it's not highlighting for me, 0 to 12. And so this would represent 1 year. So let's go back to the question now that we got all that figured out. Is it asked for when is the monthly sales less than 4,000? Right? So less than, here is the 4,000 mark. The red graph is the monthly sales. So when is it less than 4,000? Well, find those intersection points and it's less than 4,000 in between them, right? So from 4.948 to 8.052. So if you round that, 4.9 is really close to 5. So what's the 5th month? January, February, March, April, May. So from May to the 8th month, June, July, August. So from May to August, their sales are less than 4,000, which is what they say here. Okay, so now they want you to try this on your own. So you can take some time, pause the video, and you're going to try to do it algebraically, solve this equation, and then you're going to do it graphically and see if you get the same answer. So pause the video, try it on your own, and then we'll do it together. So if you do this algebraically, it says your average monthly temperature of the water in a mountain stream is modeled by this equation. And again, x equals 1. So solve algebraically to find what 2 months are most likely to give a temperature reading of 62. So we're going to plug in 62 for t of x. So we're going to set our equation equal to 62. Did I skip? I think I skipped that slide. That was the one with all the, no wonder. Y'all are going to see this and it's going to be too late. But I'm going to go back and do that slide after I finish this. I'll have to tell y'all that. So y'all don't all text me. And if I don't even know who watches these videos, but I guess I'll find out. Anyways, on this problem, we plugged in 62 for t of x. And now you're going to solve this. So you first move over the stuff that's not inside the sign. All right, so you're going to subtract the 53 and get 9, and then divide by the 18 and get 1/2. And so now you're going to let u represent this inside, this inside mess. Because remember, you can't touch any of that till you go to the unit circle. So just let u represent the inside. So now you can just ask yourself, okay, where on your unit circle is the sign value 1/2? And this is in radians. So if you go to your unit circle, the sign value is 1/2 at pi over 6 and 5 pi over 6. So you're going to take that inside mess and set it equal to those angles. So you're going to set it equal to pi over 6, and you're going to take that inside mess and set it equal to 5 pi over 6. Now you have to solve this for x. So this is where I think I just rewrote it over here. Oh, no, I didn't. So you have to be pretty comfortable with fractions here. So when you solve this for x, the first thing you would do is add pi over 2. So first I added pi over 2 on each side. So if I'm trying to add fractions, I would need a common denominator. So my common denominator would be a 6. So to get pi over 2 to be a denominator of 6, I'm going to multiply the top and bottom by 3. So it becomes 3 pi over 6. So I wrote it as the angle plus 3 pi over 6 for each one. And now you can just add the numerator. So this becomes 4 pi over 6, and this one would become 8 pi over 6. And now if you're trying to get x alone, and it's being multiplied by a fraction, to cancel out that fraction, you can multiply by the reciprocal. Because that's like dividing by the fraction. So if you multiply by the reciprocal on each side, you're left with just x. And then here, the 6's would cancel because they have one on top and bottom, and those pi's would cancel. So you're just left with 4 from this one. And same thing happens over here. You're left with just 8. So So your answers would be 4 and 8. So that's what you can type in there. And then here you do it graphically to find, oh, it's not the same question. We want to know when the temperature is below 50. So graphically, we're going to type in this equation to our graph, and then we're also going to type in y equals 50, which you can just pull up or you can change your window and find it. So we only really care about this first month. When is it below 50? Well, it starts when x is 0, when t is 0, it starts below 50 until you get to 2.68. And then it's above 50 until you get to 9.32. And then that's past 12. We're just talking about the first 1 year, right? So 9.32 on till the end of the year, till 12. So when is it below 50? From 0 to 2.68 and from 9.32 to 12 is what I would type in there. And you can click submit and check your answer. And that's your summary video, and congratulations, you have completed the tutorial. I think I'm going to stop. Well, I'll do this example for your test, and then in another video, I'm going to go back and do that slide 21 that I forgot to do. Okay, so here's an examples for your test that I thought weren't exactly gone over. This one's similar, but this one doesn't. It's not going to seem like I need to go over this because I didn't do that other slide, but it'll make sense once you watch that other video. So this is an example for the test. The only reason I put this on here is because I didn't want you to think to use this the half angle formula from your identity chart. So here you would just do the same thing where you don't touch this inside stuff. So your trig function is already alone. So you just go straight to the unit circle and you say, okay, where is the sine value? Negative square root of 3 over 2. Well, that would be, and if it wants it in degrees, it would be 240 and 300. So you set that inside stuff, which is just x over 2 equal to 240 and 300. And then how do you get x alone? Multiply by the 2, so your answer would be 480 and 600. So it's a pretty simple question. You don't need an identity to do that one. Okay, on this one, the only reason I put this on here is because I thought it was kind of confusing. It's one where they want you to arrange the steps, and it's kind of confusing on what they want. So I thought I would show you step by step. It's going to be 8 slots you have to fill, but you're going to have more than 8 options because they're going to have different factoring options. So you are going to need to know how to pick the right factoring one. But let's say you had a problem where it says arrange the steps in order to solve this. Well, the first step they want is just re-putting the problem. The second step they want is to substitute your trig function with u. Then the third step they want is actually showing the new equation with u. And then they want you to actually factor it. So in this case, you could just do X method. I think the one on your test, you have to do slide and divide. Your fifth step is you give your solutions with u. Your sixth step is you say replacing u with sine, or it might be cosine. So you rewrite it, replacing u with sine. And then your seventh step is, okay, now actually from your unit circle, which in this case, on your unit circle, sine is never 2. So that doesn't give you a solution. And on this one, sine is equal to 1 at 90 degrees. So your only solution is 90 degrees, but notice it only wants it on that interval from 0 to 90. So it only wants any quadrants, any angles in that first quadrant. It doesn't want you to use the rest of the unit circle. And then your last step is just your answer without that boundary. Okay, so if you needed those steps to help you, that is what they're looking for. So as you're working through these, let me know if you have any questions. But I am going to go back and do that slide 21 because I can't believe that's the one I forgot to do, because that's the one that I was probably have the most questions over. So anyways, I will post another video with that one. But let me know if y'all need anything else as you're working, and you're almost there. I'm proud of y'all. Let me know if there's any way I can help y'all finish strong. And y'all have a great week.